In this video, we're going to learn about Lewis structures. Lewis structure is a picture of how the atoms and electrons are arranged to create a molecule. And so we have steps to go by to draw Lewis structures. So first, we count the valence electrons. Okay, remember that the group number is equal to the number of valence electrons. And if you are drawing a polyatomic ion, you have to add electrons for each negative charge and subtract for each positive charge. And so then you arrange the atoms symmetrically. The central atom is the most electronegative atom. Usually there's only one of those. Occasionally it's not the most electronegative, but most cases it is. But it will always be the one we have one of. Alright, we bond the terminal atoms to the central atom with a single bond. The terminal atoms are the atoms at the end. That's why they're called terminal. They terminate. Right, they're at the end. And the central atom's in the middle. And then we fill in our octets. An octet is when all the atoms have 8 electrons, 8 oct, right? Except hydrogen only needs to have 2, boron only needs to have 6, and beryllium will only need to have 4. So those are our exceptions. Then we'll count the number of electrons that we've drawn. If there are more valence electrons than we had in our count, then we have to share more. And if there are less, we'll have to add additional electron pairs to the central atom. This will only occur if the central atom is in periods 3, 4, 5, 6, or 7. And the reason they can do this is because they have access to their D subshell, or sublevel, and they can hold more than 8 because of that D sublevel. And then if there are an exact number of valence electrons in your count, then you're finished. So let's look at some examples. So NH4, the ammonium ion. Alright, so first we'll count our valence electrons. Nitrogen is in group 15, right, so that's 5 valence electrons. And then hydrogen is in, has 1 valence electron, and there are 4 of those. Right? I don't know why I put electron there. So we have 5 plus 1 times 4, because there's 4 of those. And then we have this plus charge. And up here we talked about for polyatomic ions that we add for each negative and we subtract for each positive. So this is a positive charge, so we're going to take away 1 electron, because that's what it means to be positive, that it lost electrons. And so if we add those up, we'll find we have a total of 8 valence electrons. Next, we arrange our atoms symmetrically. So we'll put the nitrogen in the center, and we'll attach the 4 hydrogens with single bonds around. Okay. Then we make sure everybody has octet. So nitrogen has to have an octet. Now one line represents, this bond represents 2 electrons. So we have 2, 4, 6, 8. So nitrogen has an octet. And then hydrogen doesn't need an octet, it just needs the 2. And here it's sharing those 2 with hydrogen. And so each of those, with nitrogen, each of those hydrogens have 2 as well. We only had 8 valence electrons to use, and we've only used 8 in our drawing. So this is our final answer. The other thing that we have to do for polyatomic ions is we put them in brackets like this, and we put their charge out here. That just indicates that it's an ion, it's charged, and not a molecule that is neutral. Alright, so CO2, carbon dioxide. So again, we count up our valence electrons. Carbon has 4. Oxygen's in group 6, so it's going to have 6 times 2, because there's 2 of them, and so we have 12 and 4 makes 16 electrons. Again, we're going to arrange our atoms symmetrically. Carbon is the lone one, so we'll go in the center. Okay, next we have to give everybody an octet. Start with the center because that's the one you're going to forget. So you have 2, 4, and so then we add the other ones as pairs, and that makes 8. And now the oxygens, they also need to have 8. So this one has 2, and it needs 6 more to make 8. On the other side, the same thing. It has 2, and it's going to need 6 more to make 8. Now, we're only allowed to have 16, so let's count. We have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Well, that's too many. And so what happens is we have to take away a pair from the central atom and take away a pair from the terminal atom and make them share. Okay? And so then we count again, 2, 4, 6, 8, 10, 12, 14, 16, 18. Still too many, so we'll do the same thing on the other side, making it symmetrical. And so we take away a pair, and make them share. And we count 2, 4, 6, 8, 10, 12, 14, 16. Alright, so that's correct. Now we want to make sure that we provide nice, neat drawings, so I'll redraw my work over here for my final answer. Okay. Then we have xenon difluoride. Alright, so we count up our valence electrons. Xenon's in group 8, 8 valence electrons, plus 7 for fluorine times 2 fluorines. And so that is 14 plus 8 is 22 electrons. And so then we arrange them symmetrically. Xenon will go in the center, bond the fluorines to either side. Then we have to give everybody an octet. Again, start with the center. 2, 4, 5, 6, 7, 8. And then we do the fluorines. 2, 4, 6, 8. Same on the other side. We have 2, 4, 6, 8. Now we count. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Well, but we have to use 22. And so this is one of those cases where we don't have enough. And so we put those extra 2 on the central atom. Okay? And we always do these in pairs. Okay. So I want you to try the next one, sulfite ion. So pause the video, you attempt to do this one, and then unpause it, and I'll go through it. Alright, so we have valence electrons. We have 6 for sulfur, plus 6 for each oxygen, which we have 3 of. And then we have to add 2 more electrons to that -2 charge. And so that gives us 24, 26 electrons. Sulfur will go in the center. We would bond our oxygens together to the sulfur, and then we have to put in an octet. So we have 2, 4, 6 for sulfur, so it needs 2 more for 8. And then each oxygen has 2 here, so they're each going to need 6 more. Alright, so then we count 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. And so it equals the number we wanted, and so we are finished.